ladies and gentlemen, we are going to take a look at lesson 5.3. We're going to have two more methods for proving triangles are congruent. So with this three-sided object, this three-angled object, we are going to end up having, or figure I should say, we're going to have a number of options on how to prove that they are congruent. And so this time we're going to take a look at what's called ASA, angle, side, angle. And once again, we have to think of this as the side in between two angles. And then angle, angle, side. Two consecutive angles, and then the side not between them. All right? So let's start taking a look at what they want us to do there. So postulate 14 is what they start us off with, and it's the angle, side, angle congruence postulate. And so what it says is if two angles in the included side, so the side is in between the two angles, that's why we say ASA, are congruent to two angles in the included. So we want to make sure that we're paying attention that this means included, in between. In the included side of a second triangle, then the two triangles are congruent. And so what does that look like symbolically? Well, we're going to have angle A congruent to angle D. So we have angle A congruent to angle D. We're going to have side AC congruent to DF. So AC is congruent to DF. And that means in order for it to go angle, side, angle, I have to go from angle to side to angle. I have to go in that order. And so in fact, angle C is congruent to angle F. So you can see here two congruency marks. So that's what angle, side, angle is. We go from angle to side to angle. We can see the congruent side between the two angles. So that means we need to write a congruency statement. That means angle ABC is congruent to, well, A is congruent to D, C is congruent to F. That means B would be congruent to E. So we're going to have a triangle DEF. Notice I went a little out of order. I didn't go first, second, and third, but I'm matching up what I know from my congruent angles. All right, so now what we want to do is to do our follow-up. And I am going to have you guys we'll start this, and then I'm going to have you guys finish this, and we'll check it in class. The first thing we want to do is take a look at two angles, and then what is their included side. Because in order to use angle, side, angle, we have to make sure that you guys recognize what it means to have the side in between the two angles. So they want us to take a look at angle T and angle G. Well, angle T and G, what's the included side? Well, imagine that it's TG. Look at that. Angle T, angle G is TG. First one could be a coincidence. Angle G and angle L. So let's take a look at angle G, angle L. The included side is GL. Imagine that. And then hopefully you're seeing the pattern here and you can finish on your own. So I want you guys to finish that so now we can understand what it means to have this included side. Now what we want to do is to draw a triangle ABC in the space below. So I'm going to draw a triangle ABC, A, B, C. And I want to look at the non-included side. So I have angle A and B. So angle A, angle B. The non-included sides would be AC and BC. So A to C and B to C. So you're taking each angle and connecting it to the other vertex. You're going away from it. So if we take a look at, let's see how, I may have to just redraw my triangle every single time. If we take a look at triangle ABC, and I take a look at angles B and C. I need to have the non-included sides, the sides that are not in between those two. So that means I am using BA and CA. So once again, I can't have both the angles in the segment name. So if my two angles are BC, I have to put B with A and C with A. So I want you guys to, on your own now, take a drawing of triangle ABC. And it doesn't matter how you label yours. And I want you to do this last one on your own. I want you to look at angle A and angle C and figure out what the non-included sides will be. All right, now what we're going to do is take a look at and see if we can figure out when we get to use angle side angle. So based on the diagrams, can you use the angle side angle congruence postulate to show that the triangles are congruent? Explain. So when I take a look at what we have here, I have two triangles that share a side. And so what I do, I know that that side is congruent. So it looks like I have an angle and another angle that are marked congruent, and the side connecting them is the congruent side. So that's what angle side angle looks like. So let's look at what their explanation is. It says in triangle ABC, the included side between the marked angles is BC. Okay. In triangle DCB, the included side is BC. It's the same one. Since these sides are the same, they are congruent by the reflexive property. So that means if we look at our angles, angle ACB, so if we take a look at angle ACB, is congruent to angle DBC. We have to mark our one angle with our one angle, so that's DB to C. And then angle ABC, if we go A to B to C, that's our two mark, is congruent to DCB. Is congruent to DCB. DCB, the two congruency marked angles. And we know from what we said earlier that BC is congruent to BC. So we can use angle side angle postulate. If we take a look at triangle RST, the included side between my two angles would have to be RS. And in triangle YXZ, the included side is side XY. And since those sides are not marked as congruent, I shouldn't have put congruency marks on there, I should have just highlighted them. Since those sides are not marked as congruent, we cannot use the angle side angle postulate. All right, now we have our first theorem of the chapter. One looks very similar to our other postulates, but this is called the angle side congruence theorem. So if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. So what this means now is that if we have two congruent angles and any congruent side, we're going to be able to call the triangles congruent. But everything has to correspond. So if we look, we've got angle A congruent to angle D. That's our first statement. And then angle C is congruent to angle F. And then we have BC, the side, being congruent to EF, and that's considered the corresponding side. It's going from the two, it's the side that connects the two marked angle to the no marked angle, two marked angle to the no marked angle. We know then that triangle ABC is congruent to, we need to get our congruency statement, A corresponded to D, B would have corresponded to E, and then C was congruent to F, so triangle DE. All right, we've got this follow-up here. It says in example 1, part B, can we use the angle side congruency theorem to show that the triangles are congruent? So let's see what magic I can work here with my board. I want to pin this paper here, and then let's try and go back to here. All right. So here we go. We're looking at example 1, part B. So we're looking at this example here. It's a little bit small, but I think you guys can just look at the top of your page there. Does this show angle side, or angle side. Well, we need to make sure that we have two angles, and we do. We have angle R congruent to angle Y. We have angle S congruent to angle X. And now what we need to do is we need to make sure that our sides are corresponding. So it's RT is congruent to, if we're going to have corresponding sides, R is congruent to Y. So that means Y would need to be listed, and then T would correspond to Z, and so we would need YZ. So we need this. Do we have this? Let's check and see. Do we have that? If I look, I've got RT congruent to YZ. I do have that. I do have corresponding parts on those sides that are congruent. So I have two angles and a non-included side. So yes, that is what angle side would actually look like. All right. Doing pretty good here, guys. All right, so let's take a look at example 2. What additional, we need to figure out what information is missing. What would we need to know? So what additional information is needed to use the angle side congruency theorem? We're looking at triangles JKL and NML, and we need to, we want to use angle side. All right, which means we don't want the side to be between our two angles. So our, what we're given is KL is congruent to M. So we know that. We know that angle KLJ, so angle KLJ, is congruent to angle MLN because they are vertical angles. All right? So even though they didn't mark that, I've got to start looking at my diagrams for that shared side or this vertical angle. All right, so I've got an angle and a side that is marked. It needs to be a non-included side. So I can't follow from L to K. I can't connect those. That means I need to have two angles that are away from that side. We did non-included sides, so that means L and J would need to be in the first triangle. And L and N, we would need to go up here to N, would need to be in the second triangle. Because I can't have that congruency mark of blue between the two angles. It needs to be away from them. So in order to use the angle side angle theorem, I need the congruence of angle J being congruent to angle N. Alright, so you need to make sure we're, for angle side, we're using the non-included side. Alright, so then not only are you going to figure out what information you may be missing or may need, you're going to figure out are the triangles congruent. So, does it give you enough information to show that they are congruent? If so, state what postulate you're using. So, we are going to look at A. We've got two sides marked congruent. We have two angles marked as congruent. You have to remember that this vertical angle here is also congruent. So I have two angles, angle E and angle G, angle J and angle G there. And then I have these non-included sides. This congruence is not between my two marked angles. This side is not between my two marked angles. So that's angle, and a non-included side. This because the sides are EF are congruent to JH was given. Angle EGF is congruent to angle JGH is given by the, oh, I'm sorry, guys. Nope. What was given was angle E and angle J. I'm sorry, guys. Angle E is congruent to angle J. Here's where they're giving me vertical angles, and that's angle E. GF is congruent to angle JGH. All right. If we look at B, I have I have a side that's marked congruent in each triangle, and then I have a shared side that's marked as congruent. I I don't have any angles. I don't have any vertical angles. I don't know that anything is parallel. And so when all I have are two sides that are congruent, I cannot conclude that the triangles are congruent. All right, if we take a look at C, I'm going to be able to use the angle side angle postulate. I'm going to be able to use angle side angle because if we look at this, we have these parallel lines. All right, and when we have those parallel lines cut by transversals, I have alternate interior angles that are congruent. So angle 1 is congruent to angle 3. They are alternate interior angles. I have angle 2 congruent to angle 4. And then we have this reflexive property of this shared side of WZ being congruent to WC. So there's my reflexive property. These are two angles with the included side. All right. All right, let's take a look here at example 4. Sorry guys, I think I had a slide out of order there. We want to be able to, once again, keep proving that triangles are congruent. We want to practice this two-column proof idea that we have. So we want to use the information that's given to prove triangle ABD is congruent to triangle ABC. Remember, that's going to be our last statement in our proof. So if we take a look at what we're given segment AD is parallel to segment EC. We can see that they're parallel. We've got this marks for being parallel. And we know that BD is congruent to BC. So let's see what we can figure out here. So we're going to say, we said we're going to start with our given information. So we know that BD is congruent to BC. How do I know that? Because it is given. The next piece of given information I had was that AD is parallel to EC. So usually my first two statements are going to be right there in that given information. So then, once I know that I have parallel sides, what sort of things can I start inferring? What things do I know? Well, parallel segments that are cut by a transversal have alternate interior angles that are congruent. So if we look, they tell us that angle D is congruent to angle C. We know that those alternate interior angles would be congruent. So how did I know that angle D was congruent to angle C? That was my alternate interior angles theorem. They then tell us, the next statement they're going to say is angle ABD, so ABD, is congruent to angle EBC. So, how do we know that? That's our vertical angles. So our vertical angles theorem. Well, if we look at what we've marked in our diagram now, I'm going to unhighlight these so that you can see that those are just the parallel symbols. But if I look at the congruency I've put in two angles and the side in between them. And so I now have angle, side angle congruence. And that tells me that triangle ABD is congruent to triangle EBC. All right? Follow-up 4 says, how can we use angle-angle side congruence to prove that the triangles are congruent? So let's see if we can, if I can put these up in a double screen. So I want to try and use angle-angle side. Well, if we take a look at what they did, you know, we have our I can redraw this. We have our parallel sides, and then we have these transversals that are connecting them. We have A, B, D, and then C and E here. They gave us that, oops, the D, not C. They gave us DB congruent to BC. They gave that to us. And then they gave us these parallel sides. Well, the next statement they told us is that D was congruent to C by alternate interior angles. Well, just as D and C are congruent to each other, that also means A and E are congruent to each other by alternate interior angles. So rather than including this vertical angle here in the middle, I could have done a second set of alternate interior angles. That's what happens when I have two sides on the triangle like this. That are parallel cut by two transversals. And so if we look at that, I now have two angles that are congruent, but this side is not between the two. So this is an example of angle, angle, side. When I used to teach this, guys, and I've taught this before, what I would say to kids is, start at one of your angles, go to your next angle, then you hit your side. If we look at the one over in example 4, we start at angle D, we then go to the side, and then we go to our next angle. So that's how I know angle, side angle. All right, you guys have a checkpoint. I'm going to do number 1 with you. I'm going to have you guys 2 and 3 on your own. So 2 and 3 are the on your own. All right, and these I'm going to check in class. Okay, so you need to do these on your own. I think you guys can handle this. So let's take a look at what we have here for the two triangles. They told me they were parallel, so that meant they had alternate interior angles that were congruent, so they marked that. But then I also had two triangles sharing a side, so I have my reflexive property there for AC. So if I look at this, I have angle marked, then I have the side, and then the next angle. The side is between those two angles, so this is angle, side, angle. You guys need to mark what information you have here. See if you have angle, side, angle, or angle, angle, side. And then mark the information and pick which of those you have. If at all, remember, we could have not enough information. We will see you guys tomorrow in class.